And this is my real favorite, something that in my days when I was taking my exams used to help me a lot in solving the questions, approximation techniques. So let's begin. So in most questions requiring hefty calculations, the answer choices are generally widespread. Smart test takers need not spend significant time in reaching the exact answer. What they can do is they can just quickly find an approximate value and use the answer choices to their benefit, and in the process end up saving a lot of time. Approximately 20% of the questions in the math section of these aptitude examinations can be solved using approximation. So let's take an example here. So this is a high difficulty level question, I would say. You have to find the value of this, and these are the answer choices. So something that works very well in these cases, these questions, is that you just consider the first few numbers. The later ones would just have insignificant values. So you have square root of the first number, square root of 6 would be approximately 2.4, 2.5 something. So write it as 2.4 plus square root of, so 6 plus 2.4 is a square root of 8.4. So square root of 8.4 would be roughly 2.8 something, 2.8, 2.9. So take it as roughly 3 something. Square root of 2.4 plus 3. Have faith, the later values are going to get much smaller. They won't actually have a practical impact. So square root of 2.4 plus 3, square root of that, square root of 5.4. And this is the part I'm talking about from here. You know, I took 2.4 for this one, and rest of it all just adding up to roughly 3. So you have this value as, say, square root of 6 plus square root 5.4 turns out to be roughly, this is roughly 2.8 or something, 2.7, 2.8. So this is only going to be around square root of something like to 8.8 or something, and then just see what it turns out to be, 2.8, 2.9, and look at the nearest number. The answer is going to be 3. See, I took the first few values and the values turned out to be just close to 2.9. The later values are going to be insignificant. So this is something that works in a lot of these questions. Very often you have questions such as these: 1 plus 1 upon 2 plus 1 upon 4 plus 1 upon 8 plus 1 upon 16. Just add up the first 4 or 5 values, take out approximate answer. For example, this one, 1, this is 0.5, this is 0.25, 0.125, 0.0625. So this is this is 0.2 roughly, 0.45, 0.95 plus 1. So you have approximately 2. So look at the answer choices, and whichever answer choice is closest to 2 would be the right answer choice. So this works out very well in a lot of questions. Now let's find out the ways of actually calculating through approximation. So suppose you're solving a question, eventually you have to find out the square root value of something like, let's say, 42. You actually have to find the value. How do you do this? So before we get to this one, let's take an inhuman number. You know, if it is something as big as this one, what do we do? Of course, this won't appear on the test, but if you can solve this, you can of course solve the easier ones. So how you do it is, first of all, just count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I would always count an even number of integers, so this roughly turns out to be square root 29.7 into 10 raised to power 32. Again, the same thing, the later numbers won't have any significant value in the bigger scheme of things. So 10 raised to power 32, when it comes out, it becomes 10 raised to power 16. and then practically I just have to find out the value of 29.7 square root. And see how I do it quickly is, see 5 square is 25 and 6 square is 36. Okay, so 29.7 is of course going to lie between these two. So the difference here is 11. The difference is 11 for this entire one integer. The difference is 11 in square, and the difference between 25 and 29.7 is 4.7. 4.7 is the distance that we need to travel, and 11, if we traveled all 11 units, the value would have been 6. So 4.7 upon 11 is approximately 0.43 something. Okay, so my answer is going to be 5.43. You know, the answer to this technique always comes out to be a bit less. So practically the answer would be just a bit higher than this. Practically the answer should be something like 5.4445, something like that. You know, trust me, this is good enough. Even if you said 5.4, this would have been good enough. You know, you don't have to come to the second place of decimal at all. Just an approximation is good enough. So the value for this big thing turns out to be 5.4 into 10 raised to power 16. I took some time out and actually did it by calculator. The real answer is 5.453 into 10 raised to power 16. So see, what we have here is something very, very close. And as I said, what you get here is just a bit less than the actual value, because when I'm doing this, I'm assuming it to be a linear curve, while it is not a linear curve. It is an exponential curve. It's a square curve. So my answer would always turn out to be a bit lower than what the actual value is. So again, don't worry about this higher maths, just take care of this. So similarly, square root 42 now had to be found out. So something like square root 42 is practical. You will find such values on your actual exam sometimes. So I know 6 square is 36, 7 square is 49. If I had traveled all 13 places, the answer would have been 7, but I don't have 7 places to travel. I only have 42 minus 36. I have only 6 places to travel. Turns out to be 0.46, and therefore I would say my answer would be just a bit more than this. My answer should be something like 6.48 or something. Let me just pause the video and use my calculator. So you won't believe the actual value in front of me is 6.4807 something, you know, so we could get to the right value to the second place of decimal. Works very well, this method. You won't find it in any books anywhere. It's something that I came up with as a teenager. Numbers were one of my best friends, and I would just keep coming up with these techniques. Anyway, let's take something more practical. 4534. So first of all, take 10 square out. So you have 10 square out means 10 comes out of the square root. 10 into square root 45.34. This is very close to the example we just took. So 36, 49, base becomes 13, and I have to travel only 9.34. 9.34 out of 13 is 0.72 something. So my actual value should be just a bit more than 0.72, should be 0.74, 0.75, something like that. And 6.7475, because of course this is 6, it's between 6 square and 7 square, should be somewhere around this value. The actual value here is, of course, and I took 10 here, so yeah, 10 into 6.74, I said 67.4, the value is 67.33. So works out very well. Very smart way of finding out the square roots. Look at this one. So 2 and 2 go 7 point, so 100 into square root 7.59, or let's call it 7.6. It's going to lie between 4 and 9. The difference is 5 here. It's going to lie between, of course, 2 and 3. So 2.4 and 9.5, but I can travel only 3.6 places. So this is exactly 0.72, 2.72. So my actual answer should be just a bit more, something like 2.74, 2.75, something like that. In 200 to something like 274 or something, you know. So yeah, 275.53, quite close to where we were. Square root 240. So how do we do this? So 240 has a 16 and a 15 in it. I can take 16 out and it becomes 4 outside the radical sign, root 15. And square root 15 is just a bit less than 16. I know 40 square is 1600. I know 39 square is 1521. So this should be just a bit less than 3.9. Something like 3.8 or something, you know. So in this case, I would know 3.8 square and 3.9 square. 3.9 square is 1521. So 14.44. I would just roughly see this is approximately 0.8 and the difference is 0.6. So 3 out of 4 is the fraction. So I would say this is something like 3.875 or 3.88. So actually I'm cutting it just too fine. 4 into 3.9 also would have been okay, but I'm saying it 4 into 3.88. So it's 7.76 into 2, 15.52. So something like, yeah, 15.5 or so is the value I should be reaching out to. So something like this, yeah. So 15.49. Yeah, you'll of course So you're reaching the approximate values, and have faith the answer choices on such complex calculations wherever they are always well spread. Okay, so simply you can pause the video and do it yourself. I know 5 square is 25, 6 square is 36. The difference here is 11. The difference here is 6. 6 upon 11 is 0.54. So it should be 5.54, just a bit higher than this, something like 5.56, 5.57. 5.57 it is. Let's do it very quickly. Square root 92 turns out between 81 and 100. The difference is 19 here. The difference here between 81 and 92 is 11. 11 upon 19, roughly 0.6. Very quickly, should be something like 9.6, you know, 9.592. So practically this is how I would do it in like 10 seconds and actually save a lot of time. Approximation for multiplications. Let's take some inhuman expression just because I want to show that it is quite easy to do. So put a decimal after one place and just count 2, 4, 6, 8, 10, 12, 13, 15, 16, 17, 18, 20, 22, 24, 26. Okay, so into 10 raised to power 26. So we have 2.26. Let's round it off to 2.3. I rounded off one on the higher side. I will round off other on the lower side to just have some sort of a balancing thing. 2.3 into 8.2 into 10 raised to power 26. I can actually solve it, or I can go for approximation again. I would say, now see, this is something very interesting here. I would want to convert this bigger number into something more comfortable to work with. So I would say 8.2. I want to make it a 9 for it to be easy for me to handle. 9 means an approximate 10% increase. Okay, so if I'm increasing one number by 10%, I would want to decrease the other number by approximately 10%. So decreasing by 10% would mean 2.07 something. For saving time, I simply take it as 2. Works out fine, you know. I know that I have reduced it more than I should have, so whatever I'm getting is going to be a bit less than the actual value. So if it's 18 into 10 raised to power 26, my answer should have been a bit higher than this, something like 19 into 10 raised to power 26 or something like that, you know. So yeah, see, practically the answer is just a bit more than 18 into 10 raised to power 26. So very quickly, how you do it is just remove, first of all, make the numbers smaller and take everything else in the form of power. So if I had 374 into 792, I would say 3.7 into 7.9 into 10 raised to power 4. Okay, and then I would go about solving it, and then reduce one term, increase the other term, and rather than doing it absolutely, so if I had done it this way, that if I say I will reduce each by absolute number, if I said this is 2.0, so I increase it by 0.3, I say make it 8.5, I would get a relatively an answer that would not be as close. Even then I would not get a very bad answer. 2 into 8.5 turns out to be 17. Still, it's not a very bad answer if I'm reducing by absolute quantities. Still, I'm getting a reasonably good answer. But if I do it percentage wise, I get an answer which is almost accurate. So take one more, 337 into 72. I would say make it 3.37 into 7.2 into 10 raised to power 3, and then play around. Okay. So 10 raised to power 3 means 1000, these many thousands. I'm decreasing by this by 10%, so I'm increasing this by 10%. 3.3 becomes 3, 7.2 becomes 8, 3 into 8, so that's roughly 24,000. See, otherwise this would have taken me so long, but I know in a matter of few seconds it's 24,000. And the last digit, another thing, see, if you have really close answer choices, you know that last digit is going to be 7 into 2, 4. So something close to 24,000 and ending with a 4. Actual answer is 24,264, very, very close to where we were through approximation. Take another one, 43 into 73. So see, very quickly I have made this a 50, increase of 15%. So decrease this by 15%, roughly decrease it by 10 or 11. 62, that's approximately 3100, and the real answer is quite close, 3066. 64 into 91, so I've increased this by 10%, so decrease this by 10%, 57, 58 something. Slight mistake here, this should have been 57.5 rather, so you should get, so 5750, 5824. So yeah, you end up getting close enough to these approximation ways. And now similarly, approximation for division, very similar approach. Take some inhuman number for just to explain the concept. I say 97.22 here and 23.64 here, 10 raised to power 4 and 479. So 10 raised to power 9 here, 10 raised to power 4 here, so I'll get something like 10 raised to power 5 here, 9 minus 4, and then I have 97 upon 23.64, rounding it off on the higher side, or let's keep it at 23.64. I just want to make it 100, so I will increase it by 3%. So 100, 23.64 plus 3% would be approximately 0.6 something, so 100 upon 24 roughly. Even if I just made it 100 and I made it made it a 24, just pure rounding off would have also led me to a very fine answer. So yeah, 100 upon 24 would be 4.1, 4.2 something, so something like 4.1 or 4.2 into 10 raised to power 5. So into 10 raised to power 5, the real answer is, yeah, so 4.1 something into 10 raised to power 5. Works very fast, very quickly, you know. So even if you don't apply the percentage concept that I'm suggesting, if you just keep rounding it off and find out approximate answers, you won't be too far off ever. Let's take another example of approximation when multiplication as well as division is happening very quickly. So let's try doing it you have some really big number here. So just deal with the power first, and then just apply approximation. The real answer is this much. This is just for extra practice. Of course, this won't appear on the test, but if you can solve this, you can of course solve all the easier ones. Let me do this very quickly for you. You have 3, 6, 9, 12, 15, 18, 19 power here. 19. Now to bring this decimal here, I'll have to travel 1, 2, 3, 4, 5. So minus 5. And then to make this a 5.4, 1, 2, 3, 4, 5, 6, 7. So minus 7, because when this goes up, this becomes negative. And to make this 9.3, further minus 3. So 19 minus 15 is 4. So practically what I have here is 7. Just remove all the smaller parts. 7 into 2.3 upon 5.5 into 9.4. So this is approximately 4. 7 upon 22 is approximately 7 upon 22. I know that's the value of pi. That's 3.14 into 10 raised to power 4. So 3140 is what I want. 3238 is the real value. So very, very close. A mix of all, really, really inhuman. Okay, not very inhuman. However, we will solve this value. So see, put an 8.23 here. So 10 into 2.9 is 8.41. So this should be roughly a bit less than 2.9. Take it 2.9 for keepsake. Square root 28. 5 square is 25. 6 square is 36. So 25, 36. The difference is 11. 25 and 28. The difference is 3. That's approximately 0.3. So that means this is 5.3. 20. 4 square is 16. 5 square is 25. The difference is 9. The difference here is 4. 4 upon 9 is 0.44. A bit higher than this. We can take it as 0.5. So upon roughly 4.5 is what I have to figure out. This would be roughly 1.2. 1.2 here. 29 into 1.2 is roughly 34.835, something like that. 34.835, something like this. So yeah, 35 is what I was getting. I am close. Of course, I did some real broad approximations, and I could get to a value around 34 in a relatively much shorter span than what I would take if I were to actually find the value. All right, the next concept. I would say approximation is a life skill because you can use approximation in all sort of things. So when somebody comes to me with a business idea, okay, this is the idea on my drive back from office to home, I just keep running numbers in my mind backwards, and towards the end of the drive, I can figure out whether it's a profitable idea. Of course, what I'm doing all the time is approximating. So you can use this approximation skill for finding out cubes, cube roots, sine, cosine, tangent, log, exponents, all sort of things. I can explain you that, but this is more out of hobby, and these things do not appear on the standardized exams. They never expect you to find out these out of your head. So yes, it's good fun to just find out approximation, that if you know cube root of, for example, a 12 is to be found out, that 2 cube is 8 and 3 cube is 27. The difference is 19, but you have only 4. 4 upon 19 is a bit is something like 2.1, 2.2. So the value should be something like um, 2.22. I'm sorry, this should be 0.22 something. So a bit more than this. So yeah, something cube root of 12 should be something like 2.24, 2.525, something like that. And the right answer is 2.28, so yes, you can apply this very technique in finding all sort of stuff. Thanks for watching.